Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everyone, and welcome to Wednesday Night Math Night. Like Dr. A said, my name is Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do, which is help you feel more competent and confident in your math skills. And so we are here every Wednesday night just working through some math problems for between 45 minutes and an hour. And we just hang out and do math. Tonight's session is going to be a little bit shorter because it is the first week of school for us. And so it is just a little hectic, a little crazy. And so it is the first week of school. And so it's just going to be a little bit of a shorter session. I feel like this summer has been a little bit of a shorter sessions, but I promise, like once the school year gets rolling, we will go right back into our full regular Wednesday night math programming. So join us next week, and I can assure you we will be back to rocking and rolling. I always have a next week section because these sessions are for you. As much as I love doing this, these sessions are for you. So if there's something that you want to see me go over in the upcoming weeks, don't hesitate to comment in the comment box and let me know. Let me know what you're studying for, what kinds of questions you want to see. Is there a specific topic that you're struggling with that you really want to see me go over? Excuse me. Is there a specific question that you're struggling with that you've seen in your study guides and you're just not sure? Let me know in the comment box. I'm happy to include it in the upcoming sessions. I always like to do a little get to know you because it feels a little bit less like a computer screen and a little bit more like we're just hanging out at a coffee shop or in my living room doing math. So let me know in the comment box where you're from, what test are you prepping for, and if you could do any job, what would it be? Like if you had literally unlimited money, unlimited resources, unlimited anything, what would like the dream job be? I would say I absolutely love what I get to do, but I would love to be a choreographer for Broadway. That would be like my dream. Or to open like a big dance studio and do like choreography for the company and like operate the dance studio. That would be a big dream of mine. So where are you from? What test are you prepping for? And the dream job, like what would that job be? We are going to go over problems for pre-K through 12 tonight. We are going to go over problems for pre-K through 12. So if we get to a problem, you're like, man, that's not for me, I can assure you there will be a problem for you later on. And I always do some rabbit trails. So while I am trying to show you how to solve these problems, like in real time on a test, I will rabbit trail and kind of let you know, hey, this is information you need to know depending on what section you're studying for. All right, without further ado, let's get started with our first problem. An event manager was setting up for an event. They had 4 tables that needed to be lined up end to end. 2 of the tables are 6 yards by 3 inches each, and the other 2 tables are 25 feet by 3 inches each. What is the total length of the tables? What is the total length of the tables? So this is an interesting problem. An event manager was setting up for an event. They have 4 tables. So I'm going to draw 4 tables. That's just how I operate. And if you've been with me for any length of time, you know if we are dealing with anything that can be drawn, I'm going to. Now, God did not gift me the gift of artistry. So you're going to notice that my drawings are not always the prettiest, but they do the job. So there's 4 rectangular tables. 1, 2. The beauty of this program that I use, it has like drawing tools that I can use. So it helps. 3, 4. So 4 tables that need to be lined up. 2 of the tables are 6 yards by 3 inches each. Six yards by 3 inches. So it's 3 inches wide, 6 yards long. Let's talk about the fact that that's a really long table. And the other 2 tables are 25 feet by 3 inches. So the fact that they're all 3 inches wide, which again, a table that's 3 inches wide, this problem is clearly not like accurate, but that means that they can all be lined up against each other and not have any issues. So what is the total length of the tables is what they're asking. So they want this distance, which means that all of these distances are useless. It doesn't matter that they're 3 inches wide. So I need to add my 6, my 25, and my 25. However, I need to consider that these are in yards and these are in feet. And so I either need to convert to feet or I need to convert to yards. When I look at my answer choices, I have 2 answers that are yards and 2 answers that are feet. So it doesn't really matter which way I convert, because if the answer that I get is not there, I can just convert back. So I'm going to convert to feet because I just feel like, I don't know, that's easier. So 1 yard, some of you have a conversion sheet. Some of you have a conversion sheet which shows you 1 yard equals 3 feet. Some of you do not have that, but if you do, that's helpful. So 1 yard equals 3 feet, which means that 6 yards is going to equal how many feet? Well, if 1 yard is 3 feet, then 2 yards is 6 feet and 3 yards is 9 feet. So 6 times 3 is 18 feet. So this is 18 feet. This is 18 feet plus 25 plus 25. I'm going to use my calculator. If you don't have access to a calculator, then that's fine, but I'm going to use one. 18 plus 18 plus 25 plus 25. equals 86 feet. Now, I do not need to convert that back into yards. I do not need to convert that back into yards because I got the correct answer. Now, here's the funny thing. And this is a fault of my own. I created this problem. This would never happen on a test unless it said that there were multiple answers. But if I do convert 86, if I divide that by 3 to convert it back to feet, you're actually going to get 28 2/3 yards. So if you did that, that is also correct. However, in the actual problem, unless it says that you have the possibility of having more than one right answer, you're only going to have one right answer. But it's helpful to know that those are both accurate answers so that when you do come across a problem, if your answer is not there, you know how to convert it back and forth. Questions? All right, let's go on to problem number 2. What is the area of the shaded area of the figure below? What is the area of the shaded area of the figure below? This is a problem that was posted in our Facebook group, and I was like, ooh, that's a good one to do. So I'm going to go ahead and solve this problem. So we only want the area of this part right here. Okay? We only want the area of this part right here. So we can see that we have a rectangle. And then we have a circle. And the rectangle is being sliced by that circle. And so what I need to do is I need to find the area of the rectangle and then subtract, take away a half of a circle. Take away a half of a circle. So area of my rectangle, area equals length times width. 16 times 6. Area equals 16 times 6. When I use my handy dandy calculator, that gives me 96. Area equals 96 feet squared. So if I take this little formula and I bring it down here so I don't forget about it, I have something minus something, right? I have something minus something. So I have 96 minus half of my circle. Well, how do I find area of a circle? Pi r squared. But I'm going to only want half of that, so I'm going to divide that by 2. Area equals pi radius. What is my radius in this situation? Well, if the top to the bottom of my circle through the center is that length, then I can assume that it's 16 because this side is 16. So then this side of the rectangle has to be 16 too. So the diameter equals 16. So my radius is going to be 8 because my diameter goes from end of circle to end of circle through my center, and my radius is half of that. It goes from the center to the outside of the circle. So pi times 8 squared divided by 2. 8 squared, 8 times 8 8 squared equals 8 times 8, 64 pi, divided by 2, which is 32 pi. Now, if I do 32 times 3.14, because we can approximate pi, that equals 100.48. Can I do 96 minus 100.48 and have an actual area to work with? No, I cannot. So this problem is literally not possible. This problem is literally not possible. That's interesting, isn't it? Now, would they give you a problem like this? Most likely not. Would they give you a problem like this? Most likely not. However, it's important for you to understand how that problem works. Now, why is that not possible? I want you to consider this. Because this could actually be something that they ask you, why is it not possible? Well, now this picture is clearly not drawn to scale, and they love to not draw pictures to scale in the geometry sections. This distance right here is 16, correct? Which means from the center to the outside of this circle is 8. But this whole distance is only 6. So if we were to draw this accurately, and this was 16, and this was 8, and I had a rectangle that had a width of 16 and a length of 6, it would look more like this. Wouldn't it? Because the width of that rectangle is smaller than the radius of that circle. And so that area is not possible. It's literally a negative because that picture is so far off of scale that we end up with a negative number. Does that make sense? All right, let's move on to the next problem. Now, the next problem is literally the area of the shaded figure with a dimension that works. So I'm actually going to copy a lot of this work with us. Okay. So the way we would solve this problem is the same. It's still the same type of problem. What is the area of the shaded figure below? But now, instead of having 6, we have 12, which is going to make more sense because this distance is 8 right here. And so all of that makes more sense, right? So we're still, the 16 didn't change, which means my radius is still 8, which means that my area of half of my circle is still 100.48. What changes is the dimensions of my rectangle. Now, instead of 16 times 6, it's actually 16 times 12. So my area is going to be 192. And then when I subtract 100.48 from 192, that gives me 91.52. And in this case, we do have an answer. In this case, we do have an answer because my circle is not overtaking my rectangle. All right, problem number 3. What can we conclude about the lines that are graphed to the right? what can we conclude about the lines that are graphed to the right? Line A does not have a y-intercept. Lines A and B are intersecting lines that are not parallel or perpendicular. Lines A and B are parallel. Lines A and B are perpendicular. So what can we conclude? Well, I can see that A is right here, and I see that B is right here. And so line A, let's take them one by one. Line A does not have a y-intercept. Well, that's not true. My y-axis is right here, and my x-axis is right here. And I can see that the trajectory of that line is eventually going to cross that y-axis. It just doesn't happen on this screen. But that doesn't mean that the line itself doesn't have a y-intercept. In fact, it absolutely has a y-intercept. We just can't see it. Lines A and B are intersecting lines that are not parallel or perpendicular. They absolutely are intersecting, so let's move on. Lines A and B are parallel. Let's remember, parallel lines are non-intersecting. So parallel lines look something like this. They have the same slope. Parallel lines have the same slope, and they never intersect. But these lines very clearly intersect. So it's not C. They are definitely not parallel. Lines A and B are perpendicular. Perpendicular lines have a negative reciprocal slope, which means if line A has a slope of A over B, line B is going to have a slope of negative B over A. So let's look at the slopes of line A and line B. Line A. In order to figure out the slope, I need to find where it intersects the coordinate points. So I see one here. I see a point here and here and here. And then line B, I see a point here and here and here. Okay. So my rise over my run for my blue. I'm rising 1, 2, 3, and I'm running 1. 1, 2, 3, run 1. 1, 2, 3, run 1. So 3 over 1. Line B is rise 1, run negative 1, 2. 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 So rise 1, run negative 2. How do I know I'm running negative? Well, up is positive, down is negative, right is positive, left is negative. So rise over run, rise over run. Are those negative reciprocal slopes of each other? No, one is positive and one is negative. But one is 3 over 1 while the other is 1 over negative 2. For them to be negative reciprocals of each other, it would have to be 3 over 1, negative 1 over 3, or 2 over 1, negative 1 over 2. So they are not perpendicular. They are just plain old intersecting lines that are not perpendicular. Let's go ahead and go on to problem number 4. Joseph has a rectangular pool in his backyard. The pool measures 12 3/4 feet wide by 7.5 feet long. What is the area of the pool? What is the area of the pool? So let's talk about this. I love to draw a picture. So here is my rectangular pool that's in Joseph's yard. And it measures 12 3/4 feet wide by 7.5 feet long. What is the area? How do we find area? How do we find area? Length times width. Excellent job. Length times width. So I need to do length times width. And my screen just disconnected, so I'm just reconnecting it. No big deal. All right, there we go. So I'm going to do area equals length times width. So I need to do 12 3/4 times 7.5. There's a couple ways we can do this. We can do 12, we can convert it to a decimal and do the decimal multiplication, or we can convert it to fractions greater than 1 or improper fractions and do the multiplication that way. I will actually solve it both ways. So, decimal, fractions greater than 1. So, to convert 12 3/4 to a decimal, I highly recommend that you know your anchor fractions and decimals like the inside of your hand. 1/2 is the same thing as 0.5. 1/4 is the same thing as 0.14. 3/4 is the same thing as 0.75. I highly recommend that you know that because it's just going to make your life easier when it comes to this kind of stuff. So because I know that 3/4 is 0.75, I'm going to do 12.75 times 7.5. I do not have to line up my decimal places. Not for this. I can just multiply and then represent those decimals on later. So 5 times 5 is 25. 7 times 5 is 35, 36, 37. 5 times 2 is 10, 11, 12, 13. 5 times 1 is 5, 6, placeholder 0. 7 times 5 is 35. 7 times 7 is 49, 50, 51, 52. 7 times 2 is 14, 15, 16, 17, 18, 19. 7 times 1 is 7, plus 1 is 8. 5, 12, 3, 4, 5, 6, 9, 15, 95. So, and then I see that we have 3 decimal places we have 3 digits to the right of the decimal place in our problem. So I need to move my decimal place 3 places to the left in my answer. Now, I'm not entirely sure what 0.625 is as a fraction, but it doesn't matter because my answer is 95 plus a fraction. 95 plus a fraction is D. Now, how would I do that with a fraction greater than 1? Well, I would have to convert both of these into fractions greater than 1 and then multiply them. Remember, we can use MAD, multiply and then add. So I'm going to multiply these. 4 times 12 is 48, 49, 50, 51. So this is 51/4 times 14 plus 1 is 15. And when I multiply fractions, I multiply straight across. So 4 times 2 is 8. 51 times 15. (765/8). Then you would have to convert that into a whole number and a fraction. So 765/8. 8 goes into 76 9 times, 72. 8 goes into 45 5 times. 8 times 5 is 40. Decimal 0. And then you don't even have to finish that because you can see that the answer is 95. Now, decimal to me was easier, but for some of you, fractions greater than 1 is just going to be easier, and that's okay. So it's important that you recognize which way is more comfortable for you so that you can go from there. All right, let's move on to our next problem. Which of the following inequalities is equivalent to the inequality below? 3x plus 5 is less than or equal to 8x minus 3. All righty. So to solve this, I can quickly see, now maybe these words didn't make sense to my brain, but when I look at my answer choices, I can very easily see that I'm just solving for x. I'm just getting all of my x's on one side, all of my constants on the other, and I'm just solving for x. I like it when my x's are on the left, and that's the way my problem is. And so I'm going to move my 8x to the left. Negative 5x plus 5 is less than or equal to negative 3. Now I'm going to move my constant to the right. Negative 5x is less than or equal to negative 3 minus 5 is negative 8. And now I'm going to divide both sides by negative 5. I'm going to divide both sides by negative 5. Presenting our screen. There we go. Now remember, when we divide by a negative and it's an inequality, now it's not when you add or subtract, it's only when you divide or multiply both sides by that negative value. When you divide by a negative, this symbol in the middle flips. So this becomes a positive 8/5 because a negative divided by a negative is positive, and that sign flips. So x is greater than or equal to positive 8/5 is D. Questions about that? All right, let's go ahead and move on to the next problem. We probably have time for about one more. In the figure below, all the small rectangles contained in rectangle ABCD shown have the same area. How many of the small rectangles must be shaded so that 42% of the area of rectangle ABCD is shaded? This is a fun one. So ABCD is here. And I want to know how many small rectangles must be shaded so that 42% of the area is shaded. First, I need to figure out how many I have in total. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in a row. So 10, 20, 30, 40, 50. 50. So in total, there are 50 small rectangles, and I want 42%. So here's an interesting Like if you're really unsure how to solve this problem, half of 50 is what? 25. 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. So half of 50 is 25. Agree? This is where knowing those anchor fractions, those anchor percents is helpful. What is half in percentage world? 50%, right? So if 50% equals 25 squares, then 42% must be less than 25 squares. Agree? Well, 31 is going to be greater than 25. So that's going to be more than 50%. This is 50%. So just by process of elimination, I've narrowed it down to 2 answer choices. Just by process of elimination, I've narrowed it down to 2 answer choices. Now, if I had to swing blindly, I would guess that it's 21. But let me show you how to solve it. I want to know what divided by 50 is going to give me the decimal 0.42. What divided by 50? Because I'm going to put my part over my whole, right? This is a part, and this is a whole, and this is a percent into a decimal. Part over a whole. What part is going to equal 0.42? I can either solve this algebraically or I can plug and chug. If I'm solving this algebraically, if I multiply both sides by 50, it undoes the division. So 0.42 times 50, placeholder 0, 5 times 2 is 10, 21, 2 decimal places, so my answer is 21. If that's not comfortable for you, then what you could do is you could do 14 over 50 and 21 over 50. And if you have a 4-function calculator, you could plug that in just like a division problem. So 14 divided by 50 is 0.28. And 21 divided by 50 is 0.42. So this would be 28%. And this is that 42%. If you don't have a calculator, then you can divide it like this and then add that decimal 0. So 50 goes into 142 times. And I can already see that this is going to be 20-something%, not 42%. And so that's just part of cutting corners a little bit because you don't have all of the time in the world. Does that make sense? All right. What do you want to see me go over in the upcoming weeks? Make sure you let me know in the comment box because that is why we are here, is to serve you and the needs that you have. So let me know in the comment box what you want to see me go over in the upcoming weeks. I can't wait to see you next week. I can't wait to hear how, whether you have kids or you work in a school or you wish you worked in a school, how the beginning of your school year has gone, or maybe you're not back yet because you're from the north. And I'm going to turn it over to Dr. A. Don't hesitate to reach out to me on one of our Facebook groups. I'm happy to help you, and I look forward to seeing you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.